Okay, we're back on. Number 14. Okay, we can. Well, you might ask why we're doing this sort of. Why we're doing all these math while we're saying this is a physics thing. We need to get the math through. So when we do physics, there's nothing new. All math contained in physics are discussed here. But in any case, we're continuing on geometry. We have learned that 3 plus 2 equals to 5, for instance, right? But we cannot do, of course, 3 oranges plus 5 apples. But let's say we have this mix: 3 apples, 2 oranges, right? Then another pile, we have 5 apples, 8 oranges, right?
Yeah.
Then you can actually add them up into 8 apples and 10 oranges, right? You can do that. In physics, I mean, whatever, in life, let's say in physics, very often you have the same thing. Let's say that surface, okay, let's say this surface. I'm gonna draw this more careful. There's an object on the surface, right?
Yeah.
You push this way. You push a force behind it this way, right? Then this object takes on a force, right? It's actually the center of the mass of the object taking on the force, but it doesn't matter. Okay, well, you take on the force, right? You get that point?
Yeah.
You get the picture? Okay, now you're gonna put the same force. You're gonna push it down this way, right? You're gonna push down this way. Same force. Which way you do the same force? Which is the force you can apply anyway? Your muscle strength. This thing will move faster.
Wait, what?
Okay.
That's on the ground.
Yeah, this is an object. This is ground. There's an object on the ground.
Yeah.
This is on the ground. Okay. Your muscle, if you push as hard as you can, right?
No, what's the question? I understand the problem, but I don't know the question.
Which way? If you push this way or this way, which way you can move this thing faster?
This way.
Why?
Because this one goes directly to the direction you want to go. This one's like taking a detour sort of thing.
Right. Because in this case, in the second, they call this whatever case. In this case, right, when you put a force in it, right, this force actually has 2 elements. You can separate into 2 elements. One is the force down, one is force up, and one is force over.
Yeah.
Right?
Yeah.
Because there's the angle here. This is the angle, which means this angle equals this angle, doesn't matter, okay? This is, for instance, this is the angle, right? Your force, let's just say this is your force you put in. This is force that's parallel to the ground. This is the force that's vertical to the ground. The force parallel to the ground equals to this force multiplied by what?
Force parallel.
What's the relationship between this force and this force? Algebraically. Did you see it? You don't see it?
Oh.
F square minus F sub 1 square.
No, let's not do that. Do this. F parallel divided by F equals to what?
Equals to cosine.
Cosine what?
Cosine theta.
Do you see it?
Mm-hmm.
Because this angle is a real angle, the cosine theta is somewhere between 0 and 1. Right? Now 1. Yeah? When theta is 0, what's cosine theta? This is theta. When theta is 0, what's cosine theta?
It's 1.
you see it? Then that's the situation that when theta is 0, you're pushing this way. That's this situation. Okay? Get it? Which part you didn't get?
All of it.
Okay. You put you put a force down this way, right?
Yeah.
This force has this element and this element. Okay? This is straight angle, obviously. This element you press directly onto the ground. So it doesn't mean anything. It doesn't produce anything. Well, actually, it makes the friction bigger. But anyway, let's not greater. Okay, let's not deal with that. It has this part and this part. Okay, when you press it at an angle, there's a vertical part, there's a parallel part. Okay, this is a right angle here. Okay, you understand this, right? You understand this, right? This divided by this is cosine theta because it's a right angle. Yeah. Okay. Anything can be separated into two vertically, vertical elements. Okay. And the relationship between F parallel and F is this. Yeah? Now, theta can change, right? This theta is this, okay, is this angle. What about when theta is 0? That's F is pointing that way, right? Yeah? And when theta is 0, we just got cosine theta equals to?
Zero.
1.
Cosine theta. This is 0. Cosine theta is what? Cosine theta is y, x or y. This is the angle. This is theta angle.
Yeah.
Cosine theta is x or y.
I don't know what you mean by X.
Okay. Oh, this is x, this is y. We always draw it this way. Okay?
X.
Okay, when this point is 0, when theta is 0, what's x? What's x at this point?
1.
Yeah, you need to get this stuff, okay?
Okay.
This is what's y at this point?
0.
Yeah, okay? Also, if you draw the theta against the say cosine theta, whatever, the cosine theta looks like this, okay? Okay? You need to remember this. Okay? Sine theta looks like this. I need to get this one. Okay? Sine theta looks like this. Okay? This is sine theta. You want to remember this. Okay? Sine theta, for sine, right? A 0 is 0. A pi over 2 is 1. This is the pi. Back to 0. Back to 0. And then go down under. X go under, right? Yeah. For cosine theta, here is 1. Cosine is looking for x, right? You go to you go to pi over 2 or 90 degrees. It becomes 0, right? This x becomes 0, right? See that? At pi over 2 gets to 0, and then it goes to the other side. It goes to the negative side, right? At pi is minus 1, it's extreme. Here's pi, right? Then start to swing back. You see it? Then swing back. Here, back to 0. 3 pi over 2. When 2 pi, everything goes back. Get it? Got to remember, this is oscillation. Any kind of oscillation, sound, whatever. When you say, let's say, you don't break your sound. You don't have the this kind of thing, right? It's this wave. Okay? Does it make any point? Make any sense? No? This formula, this equation that we have.
Yeah.
This is how, yeah. And when theta is not 0, there's a number. This is the number between 0 and 1, right? When theta is not 0, 0 is 1, right? When it's not 0, I mean somewhere here, right? We're not talking about, right? So it's between 0 and 1, right? When it becomes 0? When does f parallel become 0?
Pi over 2.
Yeah.
3 pi over 2.
No, well, okay, yeah, sure. Pi over 2 is like this. If you press it straight down, this theta becomes pi over 2. 3 pi over 2, you just said that's this. You push it this way. Okay, whatever. This okay. Yeah? It becomes 0. You don't have no contribution to this direction. Yeah? You see, all of this stuff, once you give it a real world example, all means something. So when we say sine, cosine, not just some angles and whatever. Make sense? Okay. Now here's a problem that everybody will give it to you. Well, the most typical problem in sort of introductory physics. That is, give you a wedge, a slope, or okay. Then they put an object on it. Okay, ask you how fast this thing gonna move.
That's sort of undefined, because you don't know if the ground is made out of like ice or like grass.
You say the ground has no friction.
The ground has no friction.
Solve a problem.
Yeah.
How fast does that thing move?
It just moves like. No idea. I just know
What's a force on this thing?
gravity like pulling it down that way.
Gravity points that way.
No, gravity pulling it down, so
Good,
this goes
thank
that
you.
way.
Okay.
Jeez.
Okay, yeah. Gravity points down. Very good. And that gravity is composed of what and what?
What do you mean?
Remember this? Oh, you cannot calculate this, right? This way, right?
Yeah.
So that gravity, it's like you're pressing this thing at an angle, right? So gravity is composed of what? Or you can separate it into what?
What do you mean?
Which force is causing this thing to move?
The gravity.
Right. Which part of the gravity? When you press this thing at an angle, right? Does all the force? In other words, does this angle matter? When I make it really, really fast or very, very steep, does it matter to how fast this thing gonna move?
If there's no friction, then no.
No. When you drive a car, right? Very, very steep slope going down, right? Or it's very, very flat. It doesn't do anything to you. Say roller coaster, right? When it's really, really steep, right? And then really, really flat, it makes no difference.
I feel like when it's all really, really flat, you don't go fast.
Right, that's what I'm asking. How fast do they accelerate?
Oh, the slope of this line.
Yeah, what's that force? How you analyze this force?
Sine theta divided by cosine theta.
What to draw the thing?
So it's like this.
No. Just the force.
Oh,
Okay. You're not used to this. Okay, I'm gonna do it. Okay, look at this force, right?
yeah.
And then one force is going along this way, right?
Yeah.
And then one part of the force is pressing straight against this wedge, right? This is the right angle, obviously. One goes along, one goes this, right?
Yeah. Wait, what?
This is your force.
Yeah.
This is your force parallel. This is your force Okay, vertical, right? Here's your theta. Okay. So the force that actually moves this thing is what? Force parallel equals to force what? What's the difference between those two?
Force parallel equals to force. Wait, hold up.
You have a problem seeing it?
No, I totally don't.
You don't?
It's
You totally don't see it, right? Do
wait,
not
no,
see
I
it.
do see it. I do
Okay,
see it.
okay.
I do see it.
What is it? What's the difference between the two?
I need to see it this way. It's like sine theta.
Sine theta. Sine comes first, right? Sine, cosine, so to speak.
What do you mean?
when you're trying to figure out sine and cosine, right? Sine comes first.
No, I'm just trying. No, when I do it, I just try to find where the hypotenuse is. Because
Oh, that's f, obviously. 'Cause
Yeah.
this is the right angle. This is the right angle, right? Going down and going again. That's perpendicular, right?
wait, no, it's cos. Wait, no. Hold on. Wait, no, never mind. It's sine theta.
Right, right. The point I was trying to make is sine, or you can just cheat this thing. Sine is somewhat look like a side, right?
Yeah, that's
And
how
then- And then an angle here look like an eye, right?
Yeah.
And then the eye sees this side, right?
Yeah.
So this side is always sine. And cosine means somewhere come with it, right?
No, I was just confused because the triangle was this way, so I wasn't looking at it right.
No. Yeah. Oh, we'll get to that. We'll get to that, okay? You're looking at this part, right? That's sine. Cosine means like a
Yeah, like a cosine.
you
Got
know
it.
you know what a
This-
copain mean in French? Means friends. Means the coexistence. I can't find a simple word.
Co-worker. Okay.
Coworker,
let's go.
yeah. Let's say coworker is close to you, right? Close to the eye. So this is cosine. This one is cosine.
Oh,
In other words, if the angle is here, is this sine or cosine?
that's still cosine.
That's sine. You're looking at it.
Wait.
Don't
Oh shoot! I was still. Oh, yeah,
Don't-
got it.
look at a triangle that's laid up this way. Look for whether the angle is looking at it or is on the side of the angle.
Yeah.
So this way, for instance, if you draw this thing this way, for this angle, right? This is sine or cosine.
That's sine.
Right, you're looking at it. Yeah, sine. You're looking at it. This way, any kind of orientation wouldn't screw your head. Because in your head, it's like this is A, this is B, this is C, right? Sine is A, right? And then when I turn this thing around, then you have a problem with it. Anyway, right? When sine is 0, what's sine 0?
It's 0. I'm sorry.
What's sine 0? What's sine? X or Y here?
Why?
Y. Okay, at this point 0, right? What's Y here?
0.
Okay, this is sine, right?
Mhm.
What's the Y? What's sine here?
0.
Right. Okay. You need to remember this. Okay. This is a few things you need to remember in math. We hate memories, but well, you might know. My memory is really bad. That's why I hate memory. But anyway, you can use logic to supplement your memory, right? When sine is 0, that means this is flat.
Yeah.
When sine is 0, this is flat, right? Then F parallel is
0.
0, okay? Yeah. And this is, by the way, I'm just going to do a little bit more beyond this, okay? Get it, don't get it, get it. This stuff has a mass of m. You put it here. The gravity is called g, okay?
Yeah.
Okay? And then any force, any F on a force is this force parallel equals to mass multiplied by the acceleration of it, a, okay? You substitute this into this. That's ma equals to mg sine theta. Take the m out. A equals to g sine theta. Okay? So
Okay.
a, the acceleration, it relates to theta. You get it? It does not relate to mass, how heavy this sucker is. Is it a big thing, small thing, doesn't matter. Get it? Yeah?
Yeah, I got it.
All right, no. For a vector, we used an example. We didn't give the whole story of it. We just sort of did an illustration. Any vector, okay, can be separated into any two vectors, or three, or whatever, okay? Let's say you separate those two. The way to add up, I'm going to tell you the conclusion. The way to add up, let's say you have an object, right? You have all kinds, like ants moving a piece of whatever, a piece of dead insect.
Okay.
Okay, let's just get gross. Every ant's pushing in a certain direction, right? So there's ants putting in this direction, and there's an ant pushing in this direction, then there's an ant pushing in this direction, there's an ant pushing in this direction, whatever, okay? I'm just gonna, this direction, and there's an ant pushing in this direction, okay?
That's sort of depressing.
So the force on this piece of thing is you line them all up. Okay? The simplest thing to explain this is if I have a coordinate, okay?
Yeah.
Right? And then let's say you put a force here, right? Right? This force can be split into a horizontal part. Let's do this. A horizontal part and a vertical part.
Yeah.
Right? Then you put another force, right? A horizontal part, a vertical part, right?
Yeah.
So on and so forth. Then you have a force here. There's a horizontal part. There's a vertical part, right? The way to add them all up, just add all the horizontal part together and add all the vertical part. That makes sense, right? Yeah? Does that make sense?
No.
If you press something at an angle, the many people pressing in different ways, okay? You use this way, you can calculate the what's this? What's the vertical part?
I don't even know what that is.
Okay, I'll help you out, okay? What's the difference between this number? I'll help you out, okay? What's F vertical divided by F? Look at this.
Sine.
Right. Okay? So when you have an F, you can get F parallel and F vertical, right? Obviously here, right? When you have an F, you want this element and this element, right? This is F, say this is F parallel, this is F vertical, this is F, right? F vertical equals to F, what?
Sine.
F parallel equals to F, what?
Cosine.
Right on the side, right? Does English say copan? That's friend.
As
You
No,
never heard of that word,
we
right?
just say friend, yeah.
Okay. Okay. Yeah, you just say French. Okay, yeah. It's probably just French and some other languages. Copan is like, on the side, right next to you. Okay, whatever. So every force you split it up into horizontal and vertical. You add them all back up, right? Not back up, just add them up, right? There's a total number. That total number is the total force. Because you're adding the x part all together and y part all together, right? Look at this. When I draw this head to tail, right? This is the x part. I mean, yeah, x part of this, add x part of this, add x part of this. You see this? This is the same thing. Because when I draw head, end to tail, and all of these little forces, right? Yeah. So a vector, remember, a vector is anything that has a direction. Pushing is there is a direction. You punch people, there's a direction. Yeah. Anything with a direction, you cannot drop the direction. In other words, two forces, right? Let's say an object, right? You have one force 1. There's force 1, right? Let's say force 2, same side, they're going this direction. So what's the total force on this thing?
Wait, where's F force 2?
There's F1, right?
Yeah.
And there's F2 are the same, equal to F1, push also in this direction. Two people pushing in this direction.
It's F1 plus F2.
Right. You see it? However, if F2, the guy pushed this way.
Oh, it's 0.
Yeah, if they're equal, right?
Yeah.
They're equal. In other words, the direction matters. You can't drop direction. And for these things, we call it a vector. And the way to add vector is there is one force. You can get it into, this is F, call this F1, call this F2, right? Yeah.
Okay.
However, this is kind of confusing. When you look at F, is it a vector or whatever, right? Or a regular number. So we put an arrow on top of it, okay? Just to really indicate this is a vector, guys. Okay? And very often the way we do it is what we call you know what that means? Those two lines mean?
Absolute value?
Yeah, right. Absolute value in this case, right, is defined, okay? It's just it's defined as just the value of it without the direction. Okay? Let me see what else we got. Okay, very last thing. This is you already know. Let's say F1. There's F1, right? F1, right? That equals to F1, right? That's the vector equals to F1x, x, F1, y, y. Okay. This is not exactly an arrow. This is kind of arrow turned that way. Okay? It's a little hat.
Okay.
Okay. This means this when you write this, right? That means it's something in that condition of a unit length. This thing has no length to it. Length of 1, whatever unit that you have, is your unit. Okay?
So what's the use of it?
It just indicates the direction.
Okay.
If this is 1 pound, 1 kilogram, whatever, this does not change that magnitude or the absolute value of it. This just give it the direction. It's a math symbol. So when you F1, right, you get it to the x direction and y direction. This is the magnitude, this is the direction. The direction does not contribute anything to the magnitude of it. Say you change from 1 kilogram to 1 pound, right? This becomes 1 pound, 1 kilogram, unit, whatever unit you have. It does not influence the magnitude. Okay? Okay, let's say F2 equals to F2x plus. Okay, you can split up F2 this way also. Right? This is just what we said just now. You separate them up into x component and y component. Yeah? Okay. F1 plus F2 vector equals to what? Can you see it?
That plus that.
Yeah, yeah. Equals to what?
F1x. X.
Okay.
No, what's another x?
F2x.
What?
F sub 2x.
Yeah.
Huh? Plus.
F2x.
Oh, by the way, to read this, we're just doing the really lazy way. Say we have F2x. It's really F subscript 2x, right? Or you can say F sub 2x. Since we're super lazy people, we just say F2x. Since we're writing this, everybody see we're writing 2x smaller. Yeah. So you don't say F subscript 2x, right? But really it's F subscript 2x. But you can short it to F sub 2x. If it causes any confusion, right? You should say F sub 2x or F sub 2 or whatever, right? Okay. Plus what?
F1y plus F2y.
Okay. This is the same thing, right? Just x component, add them up, y component, add them up. Yeah, that's you add up the two vector. Any two vector. Doesn't have to be force. Okay. That's good enough. Bye.